Hi, this is Sharon Parlier, your instructor for course T2060, Fundamentals of Health Informatics. Today we're going to review Module 3, where we're going to talk about a PACS and what is a PACS system. So many of you have heard of a PACS system, but what does it mean? What does a PACS system mean? So PACS stands for, it's actually an acronym, it stands for Picture, Archiving, and Communication System. It replaces the films of days gone by. Medical imaging technology provides storage of and access to images from multiple modalities. So, in other words, everything's very digitized now. It's, the old days where they took x-rays and you put them up to a light and you carried them. No more. Now you're seeing they're still doing an x-ray, but it's going into it and being stored in a PACS machine. So as I mentioned, there are many different types of images that a PACS machine can handle. So these include ultrasound, MRIs or magnetic resonance images, PET scans or positron emission tomography, CT scans or computed tomography, endoscopies, mammographies, digital radiography, and of course x-rays. So what are some of the main uses of a PACS? And we'll get into each of these separately, but on a high level, it's a hard copy replacement, as I mentioned with the x-rays. No more need to carry around those x-rays or have a file room filled with them. Now they're all going to be digitized. Remote access. You can now access these images from anywhere. Much like the EMR, sometimes it's often a link from an EMR. You can access, images from your your desktop, a tablet, or sometimes even your phone. Electronic image integration. Like I said, you can integrate into, different applications such as an EMR or a RIS, a radiology information system, and it improves radiology workflow and management. So let's get into each of these uses for a PACS individually. Let's start with hard copy replacement. PACS replace hard copies, permanent reproduction or copies, and it's a means of managing medical images such as films and archiving, just another way of storing. It also decreases the price of digital storage used by the PACS. Digital storage takes, is less costly than having an archive of films. Digital copies, also referred to as soft copies, they have a space advantage over film archives. So, there's hardware and software. Hard copy would be an actual x-ray. A soft copy would be the digital copy. Next, I want to talk about remote access. A PACS system enables practitioners in different physical locations to access the same information simultaneously. This is great sharing, the ability for different doctors to view the same image. It provides physicians the ability to view their patients' x-rays or scans from outside their office. As I mentioned before, they can be on the golf course looking at it, and to make immediate clinical decisions based on their findings. This is often important. Easy access, easy decision making, improved, medical services. The next advantage of a PACS is electronic image integration. A PACS provides the electronic platform for radiology images interfacing with other systems, such as hospital information systems, an HIS, electronic medical record, an EMR. Many EMRs link directly to the PACS system. You'll often see a link, and then the image, which is often stored on another server, is able to be pulled right in to the EMR. Radiology information systems, an RIS, PACS and RIS usually work hand in hand. Can quickly see the images. Radiology workflow management. A PACS, improves the workflow management of a radiology department. PACS is used by radiology personnel to manage the workflow of patient exams. PACS is offered by all major medical imaging equipment manufacturers, medical IT companies, and independent software companies. It's used pretty often now, and it has great functionality. So how does the PACS actually work? You may wonder this. Let's start from the beginning. A PACS consists of several modalities. As I mentioned, CTs, MRIs, ultrasounds. The modalities, once the image is taken, it sends the data, to a QA workstation. The QA workstation acts as a checkpoint to validate patient demographics and other attributes of the study. It's like the checkpoint. The images are then passed to the archive or server for storage. Once this is done, the radiologist uses a reading workstation, a very high-end screen, to view the study, and then they use other software to dictate a report. So within a radiology department, you have images and you have reports. Since some people learn better by visual than by listening, I just wanted to give you a visual image of how the PACS system works. So again, we start with the modalities on the left side of the screen. You have the CT scanner or the MRI or the ultrasound machines, and the way they interface with the QA workstation is they use something called DICOM technology. It's taking the image, it's what's used when you need to take an image to a machine. Once the QA workstation validates all of its information, and usually have a technician doing that, now it goes over to an archive where the image is stored. Next, you have the doctors or the radiologists using what we call reading workstations. Again, they're high-level monitors to review the image, pinpoint, they can annotate on it, and then at the same time they're dictating a report usually, or they're writing a report. They can either type a report, or some use Dragon software to dictate a report as well. So I hope this visual image helps you. Interfaces. As I mentioned, there's a lot of interfacing going on when we use a PACS system. There's interfacing between multiple systems which provides some more consistent and reliable data. So there's patient ID and orders are sent from the HIS system to the RIS system via what we call HL7 protocol. So this is actual data, for instance, a patient's name, medical record number, the order number. Next, we look at a different type of data. The patient ID and orders are sent to a modality, for example, a CT, MRI, or ultrasound, via DICOM protocol or work list. So now we're sending that information to the actual work list, and that helps the techs, schedule their appointments. And now the images are created once it's taken and sent to the actual PACS server. Often, because of the size of the images, a separate server is used just for PACS type images. Next, a diagnostic report is created by the MD or the radiologist based on the images, and this is also saved to the RIS system. You'll often see, like I mentioned, you'll see a report and an image within any RIS system, and you'll also see this within an EMR as well. So in summary, I just want to say that a PACS system consists of the following components. There's imaging modalities such as X-ray, CT scans, MRIs, ultrasounds, the list goes on and on. There's a network. You need a secured network for the transmission of this patient information. You also have workstations, hardware for interpreting and reviewing the images. And lastly, we have archives for the storage and retrieval of images and reports. As I mentioned, this is often done on a separate PACS server for that purpose. The images are very large. This concludes Module 3. I hope you enjoyed and got something out of this module, and maybe you all know a little more about what a PACS system is. and I look forward to seeing you in Module 4. Thanks.